Why do atoms give off specific colors when heated? Why do electrons never crash into the nucleus even though they're constantly attracted to it? And why does every element have its own light signature, like a cosmic barcode? All of that begins with how atoms are built on the inside. Take a candle flame and place a small metal wire in it. You'll notice the flame changes color depending on the metal. Sodium gives yellow, copper gives green, potassium gives lilac. Nothing magical. The electrons inside the atoms are jumping between energy levels. This is the learning studio, making atomic physics feel ridiculously simple. Imagine an atom like a tiny solar system. Not perfect, but a good start. The nucleus sits at the center, packed with protons and neutrons. Electrons orbit around it, but not anywhere they like. They can only occupy specific floors, called energy levels. Think of these levels as seats in a theater. You can sit in seat 3 or seat 5, but you can't sit between them. Electrons follow the same rule. They can jump from one level to another, but never land in between. And every time an electron jumps down to a lower level, it releases energy as light. Now here comes the beautiful part. Each element has unique energy gaps between levels, so each element releases light of specific colors. When you pass that light through a prism, you get thin, bright lines called spectral lines. Those lines are so unique that scientists can identify elements in stars millions of light years away. This idea became crystal clear with the Bohr model. Bohr proposed that electrons don't spiral into the nucleus because they're locked into fixed orbits. As long as they remain in their orbit, they don't radiate energy. Only when they jump or fall between orbits do they absorb or emit photons. Higher orbit, high energy. Lower orbit, low energy. Jumping down, photon released. Jumping up, photon absorbed. That's why fireworks shine in different colors, why neon lights glow, why sodium lamps look yellow, and why astronomers can tell what stars are made of. The Bohr model isn't perfect, but it opened the door to quantum mechanics and explained why atoms are stable and why they produce such detailed spectra. And now the curiosity that takes us deeper. If electrons occupy fixed energy levels, how do atoms bond, share electrons, and form molecules with completely new properties? That question leads directly into quantum chemistry and electron configurations, and we'll unravel that next.